joining. Thank you for taking the time. Today's technical session is sponsored by NAPE UK Europe Chapter Executives, and it will be an interesting talk. But before I hand you over to the chapter coordinator, I will just walk us through a brief safety talk. Yeah, of course, I know you're in your home, so I don't have jurisdiction over your homes. So I believe if there's any fire alarm or anything, yeah, you should act accordingly based on where you are. For this event, of course, yeah, is in a webinar format. So yeah, we'll be controlling in terms of video and audio discussion. But please take note of your questions. We have a question and answer session after the speaker has finished presenting. So you'll be free to ask your question. You can also use the Q&A feature to also type your question or the chat, and we'll get to them. Thank you so much. I'll hand you over to the chapter coordinator, Dr. Chris Iwobi.
Yeah, thank you, Obeyemi. This is the first time I'll be running this session. I was asked to take over the affairs of the chapter because Gideon had some personal reasons, so you're stuck with me for the rest of the year. No escape. Thank you for coming for this meeting. It's the first in our series of lectures for this year. And we hope questions this year. So I'd like to ask everybody to, for your comment and in the coming years, so that we'll take NAPE UK and Europe forward. The chairman of the session, Nosa Omorodian, he's not here at the moment, is he?
It's not yet here.
I think
He's here now.
Has he joined?
He's joining now.
Okay. Hello, Nosa. Hello. Has he joined now? Yeah, I think I can. Hear me? Can you guys hear me?
Yes, we can.
Yes, I can hear you.
Okay, so you're welcome. We are very glad to have you here as one of the founding members behind this chapter in the UK. We know you've had to take time out from your very busy schedule to be with us, to you for attending this session with us. For those of you that don't know Nosa a big man. He's a very big man. He's a big shot in Schlumberger, and he has over 30 years experience in the industry, with early days in Filtrex. Nosa is a big professional. He has had a number of roles with AAPG. He also a member of APG, and he has been a president of NAPE in 2015 to 2016. Welcome. I'll hand over to you now. Hello, Nosa.
Unmute, sir.
You need to
Oh,
unmute.
that's what I said.
Hello, can you hear me now?
Yes, we can.
Yes, we can. We can.
Oh, well, thank you very much. I mean, I'm glad I eventually met this, and it's indeed an honor and a privilege. I always feel like I'm coming back home anytime I'm asked to come and support or participate in anything the UK chapter is doing. Are we ready to start?
Yes, yes.
Okay. So thank you, Dr. Soka. Thank you, Bubu. The UK chapter is very, very dear to my heart because it was one of my cardinal goals when I was a NAPE president to try and make sure we take the gospel of NAPE beyond the shores of Nigeria. And I'm glad that during my time, we were able to sow the seed. We established the NAPE UK chapter, and we held the first two meetings. The first one sponsored by NNPC at NNPC, and the second one sponsored by Schlumberger. So after I left, I think the ceremony for the formal inauguration was eventually done. So it's good to be back home and to come and support and listen to this. So when Osleka heard that I sneaked into town, he grabbed me quickly and said, "Look, no, sir, you must support me and moderate this session." So, I mean, the topic is very, very interesting. I mean, it's a topic. The focus area is one that is gathering a lot of buzz within the Nigerian space today. So, and the speaker is somebody I know fairly well as well too, Oshodi. Oshodi, I believe, is I'm sure his CV must have been shown. Yeah, he's a petroleum geologist. Got his first degree from Federal University of Technology, Akure, and has a master's in Newcastle University as well. He's had experience spanning over 15 years. Let me just give you one heads up. The one thing I don't like about Oshodi that he doesn't do well is that he supports a club called Manchester United. But every other thing he does very well.
Chelsea, sir. Chelsea.
Oh, even worse. Oh, even worse.
That's why he was chosen, sir, because he's a fellow Chelsea fan.
Oh gosh, we'll talk about that later. But you guys, I wish you well this coming season. So the topic is very interesting. I mean, you're all aware that the new frontiers are beginning to gather new momentum and new steam in Nigeria. And if there's any basin that should generate a lot of ginger going forward, I strongly believe that the new frontier should stand tall. Because, I mean, not only that, the federal government through the PIA, administered by NNPC, has set aside 30% of its profits from NNPC as a war chest to go into these new frontiers. So having NAPE UK chapter to come and give an expository on one of the past adventures in the new frontier, I'm sure will go a long way in adding some meat to this conversation. So I wouldn't want to steal the tender. The abstract, I'm sure you must have all seen. And I'm going to hand over to Oshodi to lead us through this presentation. Please take notes. At the end of the presentation, depending on the chairman, we'll have some time to discuss, to have comments, exchange, and questions. Thank you, and Oshodi, over to you. Oshodi, are you ready?
Yes,
Over
sir.
to you.
I am, sir. I am ready. Thank you. Thank you for the introduction. All protocols observes the chairman, NAPE UK Europe chapter, former presidents of NAPE, and current president of NAPE and all the executives. I thank everybody for welcoming me or allowing me to give this presentation on this great platform. My name is Aleksander Oshodi. As was said, I'm a petroleum geoscientist and a petroleum systems analyst. And I'm here to talk about an integrated geological evaluation of the relinquished OPL 911 within the Afikpo area in the southern Benue Trough. As was said, there's a lot of buzz going on around inland sedimentary basins. This was a presentation that was also given at the Cretaceous Basins Conference in 2019, which was organized by NAPI as well, that brought in all the people who had worked on the interior basins, the Cretaceous basins within Nigeria. So I hope you guys, everybody enjoys the presentation, and I hope I don't lose all of you all in the conversation. Thank you. The outline basically is the aim of the study, the location. We'll give a brief introduction. We'll talk about the basin evolution, methodology on this study. Am I breaking up? Hello?
No, you're not.
Yes, you are.
Okay.
Okay, so I'll try and talk slower. The methodology, the petroleum system, factors that are detrimental to the occurrence of a viable petroleum system in the southern Benue Trough in the Afikpo axis, based on previous works and all the information we gathered. We also carried out a petroleum systems evaluation, a summary and a conclusion. Hello? Hello? Okay.
Yeah, go on.
And I'll give a brief summary and a conclusion. So the aim of this study basically was to review historical data, regional geology information that we have, and evaluate key petroleum systems elements within the area using literature and public domain and some proprietary sources as well. Assess and build a better understanding of the hydrocarbon prospectivity within the southern Benue Trough. As you can see, the area that was worked on, which is OPL 911 here, has a few wells that had been drilled in the 50s by Shell Darcy. And you have the Afikpo 1, 2, 3, and 4 wells. You also have a history of some oil shows within the areas, and there are also wells that have been drilled around it in Ishiagu, Turu, Dimeneze, Bende, Ngwa, Ipe, Ogbabu 1, Mbala 1, 2, and 3 as well. So there are some activity in the 50s around there, and it's brought up it brought up interest as to what they were able to find, and as we go along, we'll discuss some of the results from those drilling campaigns. It's good to understand where we're working in. We're working within the Benue Trough, which is a major geological feature that underlies most of the eastern parts of it's a major sedimentary basin that underlies most of the eastern parts, and it trends northeast southwest within Nigeria. It extends, it's about 1,000 kilometers northeast from the Bight of Benin to Lake Chad. It's considered part of the Central African Rift System. Its southern limit is at the northern boundary of the Niger Delta, and where it dips down and is overlain by tertiary and Morrison sediments. It extends northeasterly to the Chad Basin, and it's about 150 kilometers wide. And that's a map of the Benue Trough, and the area in orange is considered part of Benue Trough. We have other parts of the West African Rift System, which are coming up in this area here. Basically, the basin is believed to have undergone 5 phases in its evolution. That's at about 750 to 550 million years was characterized by northeast southwest trends. That's of the Benue Trough sub-basin in Nigeria. At 550 to 130 MA, this phase was relatively stable. At 130 to 98 million years, which is about where the Cretaceous is, rifting began and resulted in progressive fragmentation of the Gondwana land. 98 to 75 MA, this period was a rift and sag phase accompanied by a marine transgression, and a lot of workers have worked on that as regards that Morat in Foron in 1963, most notably Peters and Ekwazo in 1982, and Benkelil and Robinu in 1983, and Remet and Dingo. From 75 million years to present, there are northeast-southwest transpressional anticline structures, which are consistent with the contemporaneously aged left lateral wedge-induced folds in the contiguous Bornu and Yola areas. And the sediments thickness in the southern Benue Trough is believed to be between 1,870 meters and 3,980 meters in thickness, and this was carried out by Onuba et al. In 2013. Tectonic evolution. 3 major models have been put forward. The RRR rift origin of the Benue Trough, a spreading ridge model by Abobo et al. In 1986, and the Olakojin model by Olalade in 1975. The evolution of this trough is believed to have involved this geologic event, rise in mantle plume, upwelling, and placement of intrusive igneous materials in the crustal stretching and thinning, and consequently rifting. Folding in the trough due to compression of different intensities from south to northwards direction, the Abakaliki anticlinorium particularly demonstrates the effect of the Santonian compressive events. The tensional movements which are visible along the trough margins formed other small sub-basins within it. And this is a structural map showing major structural features and lineaments within the basin, but also the other thing that one should notice is the areas in the sub-basins within the major basin itself that have over 5,000 meter thick sedimentary cover, which is in the red here. So you have some areas that have over 5. So this is parts of the Anambra Basin that you have that. Our study area is around here, and we don't have up to 4,000 meter thick sediment cover based on aeromag and gravity, but you have some areas within the northern, that's middle Benue and upper Benue Trough, where you have good sediment cover as well. So this also plays its own role as regards when you're assessing the petroleum system as we move forward. And this is just a normal geologic map of the area showing major geology in terms of stratigraphy across the basin. As you can see within the Afikpo area, this is the Afikpo area where we walked. The area in which we walked actually covers this whole sector here. But majority of our work was carried out when we went into the field between Abakaliki and Afikpo. And as you can see, the Abakaliki Commission lies within the middle, and as you progressively move east and west across the basin, you go into younger sediments, which is consistent with the geology of the area and the formation of the Abakaliki anticlinorium. So the methodology employed, a lot of desktop work was carried out over a long period of time. Study of the regional geology to establish sediment thickness. We also used, in some cases, remote sensing and Google Earth imagery to try and understand what the geology was to help us, pinpoint possible areas that we can carry out our field mapping, and also identify the petroleum systems elements as well while carrying out field mapping. An assessment of the petroleum system elements and processing using field data and incorporating that field data into a regional type model for the petroleum system in the area. We also carried out an assessment of well results from within and around the study area. And we also identified the limitations and challenges to hydrocarbon prospectivity within the area as well. So the first thing we did was try and establish sediment thickness. So in a lot of situations, there was no hardcore data for that at the time, because the study has been going on off and on since 2014. But we're able to get good literature from Onuba et al., which shows us aeromag data and the depth basement maps for the study area we're working on. And as you can see, these are the results of the depth basement maps within the study area. And we see that the depth basement here is about 4,000 meters in depth. And when you compare that to the Anambra Basin, where the depth basement goes up to about 6 6.5 kilometers, it begins to make you ask questions about the viability. But the thing that we must understand is there were seepages that were identified in this area, and that was why we went ahead to go on with this study. So one of the major things that also guided us was seepage information from the 1920s. It's very difficult sometimes reading some of those reports, but some of those seepage, some of that information was very helpful, and even the locals were able to show us where some of these seepages do occur. Although they are seasonal, they do occur only when there's heavy rainfall in the area. So, but we're able to see some of them. Basically, when we understand what we call a petroleum system, it encompasses an active pod of source rock, and all genetically related oil and gas accumulations, can be tied to that pod of source rock. It includes all the geological elements and processes that are essential if an oil and gas accumulation is to exist. These elements and processes must be correctly placed in time and space so that the organic matter included in the source rock can be converted into a petroleum accumulation. The petroleum system exists wherever all these elements and processes are known to occur or are thought to have a reasonable chance or probability of occurrence as well. So these are the things that we are trying to do when we're evaluating the petroleum system. The evidence of this possible petroleum system within the area, the hydrocarbon seepages, as I said, within the study area, first described scientifically in the 1920s by the colonial governments in the Afikpo area. The occurrence of an active system in the neighboring Anambra Basin is also a sign as that, and even in the middle Benue as well. Source rocks are identified based on regional information and mapping in this area are the shales of the Asu River group and the shales of the Eziaku group, and potentially the shales of the Mamfosing limestone, which are possible source rocks, since most occurrences are restricted to areas around the Calabar flank. Reservoirs that can be identified or can be looked at are the sandstone formations of the Eziaku group as well. And the seals are potentially the intraformational shales within the Eziaku group, which occur with these limestones and were observed within the field as well. These are other evidences that link us to the possible petroleum system. And one of the things that we look at is we look at the stratigraphic chart and we look at what the sea movements were at the time. There are a lot of transgressive cycles, and we do know that some of these rocks within the Eziaku group and the Asu River group were deposited during what we know as Cretaceous ocean anoxic events. So they do have the potential to be good source rocks. There is potential for high preservation of organic matter within them. So understanding the stratigraphy and geology also allows us to have a picture of how some of these petroleum systems elements will be aligned within the basin. And if you understand their ages, this also helps as well. So this gives us a good example of how we should approach some of these studies, especially when you have very limited subsurface data. So looking at the literature on source rocks, a lot of workers had worked on some of the source rocks. Professor Akwade reported total organic contents of 2% to 5% within 90% of the sample populations in the Eziaku shales. He also put TOC contents within the Ogu ranging from 0.34 to 0.7, which are in very good source rock, but with most values between 0.5 and 0.7. So they may not be, like very good source rocks in terms of their TOC. It's the HIs that also are important, but we had very little information on that. The highest concentrations of organic carbon are present in the Lokmanta shale member of the Eziaku group with TOCs greater than 3.5%. And this unit is characterized as an oil shale member of the Eziaku group with proven TOC contents above 7.5. And this was work carried out by Professor Ekwazo and Unoma in 1990. Dr. George Unoma in 1990. The highlighted conditions will classify the Eziaku group, especially the Lokmanta shale member and the Ogu shale, as good to excellent oil source rocks within the southern Benue Trough. Akonde noted that the Asu River group shales are over-matured with VR values of 2.46 to 4.35%, with notable intrusives and hydrothermal effects. VR values of the overlying Esiaku shale vary from 0.7 to 0.93, indicating some level of maturity. And the sharp contrast in VRU values between the Esiaku group and the underlying Asu River shale suggests that the unerated Turonian sediments were subjected to thermal effects associated with the Santonian recognized in the Asu River group sediments. So the effects of the emplacement of lead zinc and the igneous intrusives within the basin affected the Asu River group more than the Esiaku, as observed from the geochemical character and the VR values within VR values taken from within the basin. So these are some of the charts of summary source rock qualities, source rock quality on the basis of rock val parameters in southern Benue Trough and the Anambra Basin. So we're looking at plots of Tmax versus HI for shales and coals in the southern Benue Trough. This was adopted from Professor Akonde's paper, 2011 paper. And as we can see, the Ogu, Esiaku, and Mamo coals, we're looking mainly at the Esiaku and the Ogu, but we have very little Ogu in the area. But these are the potential source rocks we are looking at within the southern Benue Trough. And as you can see, Esiaku is plotting with TOCs, very low HIs, but Tmax values show that they are mature. So understanding this means that we may need to find a situation where we have to back model this or reacquire the data and find out what exactly the original TOCs and HIs were. And it's the same thing here. But the Lokmanta shale has the best HI values and source rock qualities within the area. The Ogu and the Esiaku are showing low HI and TOC, low HI values or low potential for source rock quality. But we also believe that this is because of the effects of maturity, and we'll show that in the modeling process. So the representative HIs and TOCs we are seeing in these results are not representative of the original source rock character. This is either a source rock that has been spent or has reached a level of maturity that is not showing its true source rock characteristics. And we can't look away from them because we know that there is evidence of seepages. There are evidences of seepages within the area. So looking at this geochemical information, we also have to find a way of understanding what the true original values are, and that may mean reacquiring more data and carrying out more analysis as well. So source rocks in petroleum geology, source rocks refer to organic rich rocks with hydrocarbons, from which hydrocarbons have been generated or are capable of being generated. Source rocks believed to exist within the study area at the Asu River group and the Esiaku shales. These rocks are believed to be thermally mature within the southern Benue Trough, with VR values exceeding 2.43% in the Asu River group and those in the Esiaku varying from 0.7 to 93%. That means basically they are within, the Asu River group is spent and the Esiaku is within the mid oil window to late oil window range. So these are not, the TOCs and HIs that we see are not representative of what their true potential are. The sharp contrast in values implies a large variation in thermal regimes of these two formations as well. And in the field studies, both source rocks were identified and do like potential sources for hydrocarbon visually when you visually observe them. The only difference is that we saw minor bioturbation in the Esiaku shales in the field and seem to be contrary to what is expected of shale deposited in anoxic environment. So we could be dealing with an area where there must have been some localized anoxia as well within when the Esiaku was being deposited. That's why we saw some of the bioturbation. The bioturbations observed in the outcrops of the Esiaku shales implies a reduction in its potential to be good hydrocarbon source rocks. However, conclusions on this potential cannot be drawn as a result of only field analogs, as observed outcrops may be of those deposited at the end of the Cenomanian Turonian ocean anoxic event. Geological setting of the Abakaliki, Ishiagu, PBZN districts in the southern Benue Trough, and a basic geological setting of most of where the source rocks are. And as you can see, the one in pink is the Turonian Esiaku shale, and that's its distribution. And the shales of the Asu River group are within the orange. And within that area, you can see around Abakaliki, you have a lot of Cretaceous intrusives. You will see a lot of these in the Abakaliki area and in Ishiagu, but within the Afikpo axis, there is very little observation of that in the field. Then you do have some volcanics as well present within the Esiaku as you move northeast of Abakaliki as well. Why we believe that there are source rocks in the area is when we look at global distribution of anoxia during the Cretaceous ocean anoxic events, you can see this area here being the where we would have the deposition of the Benue Trough and the West African and the Central African Rift system here. This is Africa, this is the Atlantic. You can see these areas, these are sealed sedimentary basins. These are areas where you have restrictions in terms of water bodies, and you have pore mixing between the ice caps and the open ocean. So you are likely to have some form of anoxic or suboxic environments within the water table, which allows for preservation of organic matter and deposition of this preserved organic matter within the sediment. So that's why we do believe that. And these are early Cretaceous to mid Cretaceous anoxic events, which tally with the deposition of the Asu River group and the Esiaku shales as well. So that's why we believe there are source rocks there. And the evidence is also, when you look at it, source rocks will be laminar, they will be dark in observation. If we look at a typical, what we'll call the best source rock in the world, which is the Kimmeridge clay, you expect it to be a dark shale, not too dense, well laminated, very little bioturbation in it. And that's what we saw in outcrops of the Asu River group, although we did identify two different fascies within the Asu River group around the Abakaliki one which was light gray, but we did see very dark gray laminated source rocks. And this is within the Abakaliki axis, and this is the Esiaku around the Akaeze. There's a river by the bridge as you're getting or moving towards Akaeze. That's where we're able to see this outcrop as well. So based on field observations, the shales of the Asu River group, based on previous works, field mapping, have been identified as a potential source rock for this study. So these shales show strong laminations and are very dark in color, implying deposition in very low energy settings. Based on the existence of the Cretaceous OAE, we can assume that these shales are potential source rocks for hydrocarbons. The examination of outcrops in the Abakaliki, Igba, and Amago axis show variations in the shales color and dip directions. The shales in the Amago area are light gray, do not have any distinct laminations, with the deep directions of the shales being 12% northeast. Visual observations based on color make us conclude that they may not be as organic rich as the shales observed in the Abakaliki town and the Igba axis. The shales around the lead zinc mines in the Igba have dips of 10 to 20 degrees south, and they are heavily fractured and very fissile. Whole samples are hard to obtain as the shales crumbles once contact is made with the hammer. These shales are very dark in color and look like they would have been organic rich in their immature states. The disintegration of these shales observed in the field could be associated as a result of high pressures associated with the original depths of burial and effects of the Santonian tectonic episodes within the study area. As regards reservoir rocks, a petroleum reservoir is a subsurface pool of hydrocarbons that contained in porous or fractured rock formations, or rocks that have the sufficient porosity to contain accumulations of oil and gas. The sandstone facies of the Esiaku group seem to be possible reservoirs in the southern Benue Trough. The downside is that they are sandwiched within shale members with their thickness is not more than 15 meters in most places where they were observed. The 6 lithofacies of sandstone units of the Esiaku group identified by Amajo in 1985 at the eastern flank of the Abakaliki Anticlinorium showed that many of them are well-sorted sediments and range from very fine to coarse-grained sandstones and occasional conglomerates in a general coarsening upward sequence. Other sandstone units of the Asiaco group, which may probably be potential reservoirs, include the Amasiri sandstone and the Ajala sandstone. The Amasiri sandstone is highly indurated and cross-stratified with lots of bioturbation present. And these sandstones of the Asiaco group were encountered between Okwezi and Afikpo. This sandstone vary as you move south from Okwezi to Afikpo. 4 major types were identified in Okwezi, Akpoha, Ibi, Amasiri, and Afikpo. The sandstone around the Okwezi-Akpoha axis had very few observable sedimentary structures identified within them and were extensively bioturbated. Grain size range from very fine to medium grain matrix supported sands that contain a lot of calcite cement. In some outcrops, grains could not be distinguished, and the sandstone had large cannonball concretions of carbonates within them. The sands in the Amasiri axis were similar, cross-bedded to those encountered with the Afikpo area, but had less carbonates, more silica cement in them. The sands were intensively reworked and contained fine medium to coarse angular subangular grains. The dip measurements within this sandstone range from 10 to 12% south. The sands of the Afikpo area showed diverse range of sedimentary structures in them. This included crossbeds, herringbone structures, and trough crossbeds. They were also marked erosional surfaces, channel fills, which had large pebbly grains present in them. This sandstone in the area are bioturbated, have a wide range of grain size, and are also matrix supported and contain silica cement. These are some of the pictures of some of the sandstones that were encountered within the study area. These are the ones in the Akpoha Okwezi axis, which have the large cannonball concretions, as you can see, and a lot of calcite cement. And these are the ones, this is also Akpoha, it's near the rice farms, Okwezi and Amasiri axis as well. We also look at the reservoir rocks. We compared well results from databases that were available, the Eden database, and the total of 18 wells were drilled within close proximity to the study area. 10 of these wells were drilled to establish stratigraphic succession. So some of the wells I showed you in the first map were actually drilled not to locate hydrocarbons, or they were not drilled to target hydrocarbons or potential traps. They were drilled to establish stratigraphic successions in the early stages of exploration prior to when oil was discovered in the delta. Because of the seepages that were discovered in the Afikpo axis, Shell the axis started the exploration and started to move down south. And the maximum depth for these wells that were used for stratigraphic tests was 2,237 feet, which is the Mbala 2 in OPL 907. All the stratigraphic tests were water wet, so they were plugged back and abandoned, and this includes all the 4 wells in the Afikpo axis, Afikpo 1, 2, 3, and 4. The first deep well in this area was Umuna 1 in OPL 207, which TD'd at 7,525 feet, which is in the southwest of where we are of our study area. The well was drilled in 1955. It tested an anticlinal structure on deductions from field mapping. There were weak hydrocarbon indications. DSTs revealed traces of sand, traces of gas and water. The reservoirs were also of poor quality. Similar results were also observed in Demineze 1, which TDs at 10,512 feet, and Bende 1, which TD'd at 11,534 feet within OPL 207. This also targeted similarly an anticlinal feature inferred from field mapping, and the 2 wells were drilled in 1959. So that's the map I showed earlier as well, highlighting our study area and the 4 wells and the locations of all the other wells which we're discussing not too long ago, Demineze, Umuna, which are within OPL 207. And this is a basic breakdown of all the wells within the area, what they targeted, when they were drilled, As you can see, some wells were drilled in 1938 to establish stratigraphic successions. Mbala to Ishagu, Afikpo 1, 2, 3, and 4 were drilled in the 50s. Omuna was drilled in 1955. And that's the first well that was classified as a new field wildcat. And based on the information, the deepest formation that it drilled was the Asu River group. There was weak hydrocarbon indication, tested traces of gas in 3 intervals, well bottomed within the Asu River group. And the sands were also very tight. You also have other wells which were new field wildcats, abandoned and dry Ogbabu, located much younger Calabar flank, oil and gas shows, that's within the Unkoro group. Newfield wildcats, which is a Deminese one, stopped at the Eziaku formation. 2 thin gas bearing intervals were encountered, plugged and abandoned. Bende one, same thing. A lot of them weak shows or they were abandoned. So that doesn't give us a lot of confidence as regards potential reservoirs within the area as well. We also looked at the seal rocks or cap rocks. And these are rocks with low permeability that impedes the escape of hydrocarbons from the reservoir. Common seals include evaporites, chalks, and shales. Analysis of seals involves assessment of their thickness and extent such that their effectiveness can be quantified. It is evident that the sandstone members of the Eziaku group are sandwiched in the shale members based on field observations. This implies that the same rock unit which serves as the hydrocarbon source may probably serve as a trap or seal, especially if you are dealing with sub-basins and areas where you have structural lows and highs. Field observations show potential seals have been identified, which are the Eziaku shales. They were observed to be juxtaposed against the sands in areas where faulting was identified. That's around just outside Afikpo, around the Amasiri area as well. The deep directions within these shales range from 10 to 12 degrees south as well, which is consistent with all the other rocks present. And that's one of the shales. That's a sandstone. That's another body there. So these are definitely shales that we saw. And I think that's the fault plane that we're looking at here as well. So these are areas that we looked at and weren't able to really identify regional seals. One of the biggest issues we've seen there now is potential for, or the lack of a regional seal to be able to hold the hydrocarbons. Then also we looked at the factors that are detrimental to the existence of a viable petroleum system, and that's the magmatism and volcanics and the lead zinc mineralization. We also looked at sediment thicknesses as being a problem because we don't have very good sediment thicknesses within that basin. The occurrence of oil seeps, the availability of conventional petroleum systems elements within that area, then also poor drilling results in the area within close proximity to where we are working as well. Just a brief on the magmatism. So we also looked at the background to the magmatism. It's highly diversified and volumetrically restricted Mesozoic to Cenozoic magmatic products, which are scattered throughout the Benue Reef system. Key periods of magmatic activities have been recognized based on argon 40 and argon 30 ages, one at 147 to 106 million years, then one at 97 to 81 million years, and one at 68 to 94 million years. The trace elements and SRMB and PBI stope determinations performed on selected basaltic samples allow 2 groups of basaltic rocks to be identified, a group with a theolitic affinity and a group with an alkaline affinity. Geochemical data suggests that 3 types of mantle sources were involved in genesis of the Mesozoic to Cenozoic basaltic rocks of the Benue without significant crustal contaminations, and enriched subcontinental lithospheric mantle from which the theolitic basalts were derived, a He-mu type plume component from which the alkaline basaltic rocks originated. And He-mu is a basalt that contains uranium 38, 238, and over 234 lead. 234 lead within it, those isotopes as well, those isotopes for uranium and lead. So a high mu plume. Then we also have a depleted atmospheric mantle N-mob type source, which was involved in the genesis of the alkaline basaltic magmas. According to one, the postulated location of descent, that's the St. Helena's hotspot in the equatorial Atlantic, is about 130 MA, and two, the isotopic composition of the alkaline basaltic rocks of the Benue Trough and their geochemical similarity with the basalt.
Sorry, Oshodi, I think we have about 5 minutes more.
Okay, sorry. So I'll just go. I'll just go past. So basically, trying to understand. Basically, what this tells us is that you have different magmatic activities. One of them, the rocks that are associated with them, does not contain hydrocarbons within the crystals that were deposited within some of the veins. And subsequently, there was another magmatic activity, and the mineral assemblages associated with that also contain some hydrocarbons within them as well, which were identified. And this was also identified by Professor Akode in one of his studies. And that tells us that there was a period where there was magmatism and there was no generation of hydrocarbons. And subsequently, after the magmatism, there was generation of hydrocarbons. And when the next magmatism did occur, you had that. Then also the distribution of the lead zinc mineralization within the basin. You have more barytes as you move northwards. You have more lead zinc within the Afikpo basin and the southern Benue Trough, which is also consistent with the interactions between the hydrothermal fluids and the sulfides within the source rocks that are present. And those sulfides are what's allowing the lead zincs to be coming out and being deposited. So, and the presence of sulfides is also indicative of heavy anoxia. You can see that in some of the source rocks here. This is an unaltered Asu River group within the lead zinc mine. This is an area that has been leached, and these are the high pressure shales of the Asu River group, which are present around the mine as well. So presently sediment thickness is limited within the study area. There's issues regarding sediment thickness as well as why we don't have a viable petroleum system. So the areas we're looking at has very low sediment thicknesses present, which were identified by previous workers. So the information that we also looked at the oil seeps. I discussed that.
Let's move towards your conclusion and summary.
Okay, so basically what we're able to establish was we're able to build a 2D model of the basin using the information from the field mapping, and that was able to allow us evaluate the petroleum system. We're able to properly define the geologic history of the basin using the information from published works and from our field mapping. We're able to look at the water depths, how the basin evolved through time. We're able to see how we use the multilithosphere model. We used information from the aeromag and gravity and regional information as regards the basin in terms of the stable platforms that are around the basin. And that we used to build a heat flow history, looked at the information as regards how the heat flows affected the cooking of the source rocks within the basin. We looked at the subsidence histories, tectonic and the model subsidences. We're able to match them. We used a cross thickness of 30,000 and a mantle thickness of 95,000 meters. That's the first geohistory model. As you can see within this area, the basin deepens with sediments coming in, and subsequently it starts to shallow and you start to have erosion till present day. So those are some of the basin models. This is a normal regular basin model without inputting the intrusives. But when you look at the basin model here, by the time you put in the intrusives, that changes the entire maturity profile for most of the rocks within there. You have them normal maturity profiles, but by the time you put in the intrusive, the maturity profile throws everything into late oil window, dry gas window. And that's the temperature profiles, and you can see the temperature spikes associated with the inputs of the intrusives as well. So we also looked at expulsion of hydrocarbons and the transformation ratios within the basin. So we looked at how the Santonian event stopped everything in terms of, you had everything going really fine in terms of expulsion and generation of hydrocarbons, but by the time you had the Santonian compressional event and uplift, everything leveled off. Expulsion basically just tapered off and dropped off. So as you can see, all the profiles for all the models that we made shows a peak in expulsion, but because you were burying it deep, and then all of a sudden you take it out of that temperature because you had the uplift event, expulsion basically ceases. Then in the areas where you have the volcanics, basically you just have the intrusives and the magmatic intrusions basically blocking off those rocks. So that means you basically killed off the source rocks as well. So with that information we did from our 1D field mapping, we're able to build a conceptual geologic model, and that one we inputted it into a 2D model, built a 2D regional model for the area as well. And we're able to look at all those maturity informations, and we did find out that maturity is increasing as you move towards the Afikpo axis. Our modeling supports the occurrence of oil seepages due to the short period of time between expulsion of hydrocarbons and the deposition of the reservoirs. A lot of the expelled hydrocarbons will be lost. The occurrence of these seepages in fractured shales also is described in published works, also could be tied to fractured seals as a result of the Santonian event. We also looked at leakage and from underlying formations, and we can see very high leakage values based on the models within the area.
So because of time, so we don't get kicked out, do you have a concluding slide? And then we can probably have...
So basically I have a petroleum systems events chart, and then also in conclusion, using a combination of regional desktop studies and information, we're able to, modeling well results, we're able to conclude on the prospectivity. We believe that there are limitations to this study as regards subsurface data. There was potential. This study actually started as a result of looking at potentials for unconventional resources present within the area, but the occurrence of the lead zinc mineralizations and the fracturing of the Asu River group is one of the issues, and the emplacement of those igneous intrusives is also an issue as regards the potential for unconventional resources. As regards conventional resources, we look at it that the source rock never reached maturities that were high enough for it to generate as much. And with the issue of the erosions and the loss of seals, potential seals, if we look at the Ogwa as one of the regional seals, because it's a regional shale in the area as well, we have very little Ogu in the study area. Most of the shales or potential seals are within the Asu River group. So the risk implications are high due to the duration of expulsion, the Santonian uplifts, subsequent erosion. The risk regarding trapping, preservation of expelled hydrocarbons are also high. Poor preservation, poor reservoir properties, porosity and permeability due to poor sorting, being matrix supported. A lot of things are not working in favor of the southern Benue Trough, and even its potential as an unconventional basin is also reduced because of the lead zinc mineralization present within the area. Thank you.
Well, thank you very much.
Sorry I took so long.
No, it's all right. It was very, very educative. I mean, it was quite enlightening. It was very detailed, and you must obviously a lot of efforts have gone into this to try and show all the breakdown and to anchor the arguments. I mean, I think you did a very good job. I think it was a very good presentation. I would not spend much time in trying to summarize it because of the time spent on the presentation. I'll allow others to ask their questions. But a quick one. I mean, for those that joined late, the topic of the conversation of the presentation is integrated geological evaluation of the Relinquished OPL 911. And the author did a good job in giving us the outline. He talked about the challenges they encountered. Obviously, he was able to demonstrate that in the course of his study, there were evidences of source rock. The identified group and was able to equally establish, shows that reservoir rocks were established as well. The very three tenets of what you look out for Yeah, when you're looking for oil, I mean, he demonstrated that the source rock as Asu River Group and the reservoir rocks were equally demonstrated. There were 4 major reservoir sands, and obviously the seals as well. He argued that the same shale that served as a seal source rock are suspected to double as the seal rock as well too. And he was very, very frank in talking about the challenges they encountered, despite the fact that 18 wells were drilled, 10 of which were focused basically on trying to understand the basins better, despite the fact that there were revelations of traces of gas and water through DSTs, and despite the fact that there were seasonal seepages as well that tend to lend credence to the fact that the place could be petroliferous. There were concerns about the thickness of the sands, and the drilling results were not very encouraging. And in summary, we all listened to the conclusions. So I thought it was a very, very incisive and a very, very interesting conversation. And I will appeal to Dr. Ewobi and the UK chapter to ensure that this presentation equally gets across to NAPI. And if possible, some point try to organize a separate with AUPRC as well, or the NSAP group, for them to equally see, I'll be clear on this from a consult, a perception and the view, so they have enough menu to compare independent results with theirs and hopefully be intention. And I did ask in the course of presentations, if anybody has questions, please try and put the questions there so we can So, I mean, before we start taking the questions, let me start.
I didn't hear a question, sir.
Okay, I thought I lost you for a minute. So just a quick one. Let me start. If I'm a businessman and I'm interested in coming to take a look at this inland basin, and I listen to your presentation, I leave here very, very confused on how to make sure. From what you said, I mean, it didn't look very encouraging.
No,
and
it's not very encouraging, yes.
Yeah. So, I mean, what do we need to do differently? How can we turn it around?
Well, there isn't much you can do. The geology itself has already changed the entire scenario in terms of its prospectivity. It's not one of the deeper parts of the sub-basin. It's not one of the deeper sub-basins within the Benue Trough. As I said, I showed the map with areas where you have thick sediment packages, over 5,000, over 8,000 sediment thickness. In this area, the sediment thickness is just about 4,000. So that's limited. It doesn't reflect the original depth of burial of the sediments, because for them to actually, for the source rocks to actually attain maturity and generate and expel hydrocarbons, they have to have been buried above 6,500 meters within that basin. But because of the uplift events, the emplacement of the magmatism and volcanics in the area, as well as the lead zinc veins, it basically just, it doesn't make it very, very, very viable. There are a lot of things working against it. You're on mute, sir.
No, thanks for that. I think before we take Dr. Jackson, I think there are a couple of questions on the chat room. Let me take those ones first. There are two questions from Dr. Iwobi. Number one, what are the estimates of amount of uplift and how did you arrive at these estimates?
Okay, as regards the estimated amount of uplifts that we arrived at, we didn't have any calibration data to evaluate that. We did not impute any uplift scenarios. All we did was we inputted an erosional scenario.
Okay.
We didn't use any uplift scenarios. So what we did was we deposited the basin. We deposited sediments within the basin. Then what we did was we dropped the water depths and eroded. So what we did was we eroded maybe about 4,000 to 5,000, 3,000 to 4,000 meters of sediments within the area. We didn't do any uplift scenarios because we didn't have any major controls stratigraphically and structurally on that.
Okay. I think his second question has been answered towards the concluding part of your presentation. So I'll allow Chris to ask this question now. Chris Jackson.
Okay, thank you very much, Dr. Omosorodion. I believe I'm being heard.
Sure, you're being heard.
All right, thank you, sir. Wonderful work, Oshodi. This very detailed, and I'm always interested whenever I see field work because it calls for the real essence of geology, actually going into the bush to carry out studies. Yeah, I actually listened from the beginning of the presentation, and what caught my attention was around the areas of the reservoir that you said were bioturbated. So my comment around that will be that it's not, it's a generalized statement to just say that the areas bioturbated will account for a reduction in reservoir quality in terms of maybe poropen. You know, it calls for a more detailed geological studies because it will be necessary to actually identify the trace fossil present, then try to classify them and group them into the actual ichthyophacies. So at the level of that ichthyophacies, that will be the point where we will know, okay, which ichthyophacies was the bioturbation, because they are proven studies and well established internationally and locally of some types of trace fossil elements and bioturbations that are even blessings to the reservoir in effect. I mean, enhancing the reservoir quality, like when you talk about thalassinoides, planolitis, chondritis, as against if it were the ophiomorphous, asperosomas, diplocriterion.
All right, Chris, let's round up your questions.
Yeah. So that's just, so it's necessary to actually identify it. Then we know that, okay, it was this type, then it was, it impacted it negatively in terms of the reservoir quality. So thank you very much.
Chris, thanks for your comments. Let's take, guys, time is of essence. Let's take that as a comment. And in all fairness to Oshodi, he did say that there's need for more detailed studies addressing those issues. So I can see K's hand up. I can see Giwa's hand on. Let's start with KK.
Yeah, thank you.
KK, you're on.
Okay, thank you. First of all, great talk, fantastic talk. One thing I think NAPE should also do, this talk should actually be at a workshop, where we come in for the whole day and take 2 or 3 of this type and actually have robust conversations. There's a lot packed into it for the typical 1 hour technical talks. So thank you so much. This was fantastic. My question is, I didn't hear, again, maybe it has to do with time. I didn't hear anything about structure. I didn't hear anything about fault seal. I didn't hear anything about seismic, maybe not seismic at the time, but after the fact, do we have any 2D seismic, in which case we've...
There is no seismic in the area at all.
Even now?
Even now, there is no seismic in the area.
Okay. Thank you. So those are, great talk, like I said.
So it's basically trying to take field observations, regional desktop study information, and try and build a conceptual model of what you assume should be there. If, as you acquire more data, you can update your conceptual model and have a better understanding as you move along. So the whole idea of the study was, we do field mapping, we know how to draw cross sections and build 3D models from field mapping. Why don't we do that and build a petroleum systems model and see how this impacts the petroleum system evaluation of the block?
I think with the seeps and all that we see, NUPRC or somebody, should get some 2D very cross grid.
Yes,
and then,
I agree.
That. So yeah, thank you so much. Great work. Thank you.
Excellent, KK. I mean, that was going to be my conclusion as well too. I mean, if from desktop studies you're able to establish such positivity, it's important that there's a budget that's been set aside, 30% for exploration. It's important that this kind of conversation should be brought to the attention of those that are in charge of that budget to see how much of it can be allocated towards unraveling and opening this place up through more acquisition of data such as seismic and co. Yeah, Gideon.
Thank you, Chairman. I want to thank Oshodi for such a wonderful talk, well put together, well done, great talk. Also to echo Sakeke's comments around workshops to discuss this, because I think you've done a lot of work that will really benefit from a longer time looking at the picture. Mine is just a comment and contribution. As someone who has explored in basins that has volcanics in them, the approach from a new ventures frontier exploration perspective is to be careful around making conclusions that is, like you have rightly commented, that we don't have enough data sometimes to make them. Just to also correct that some of the conclusions that we tend to reach based on the fact that volcanics are present does not necessarily mean that we can't rule out, we can't come, just to say simply, we can't really jump to conclusions sometimes. So if I may advise, something that could help from an business, from an exploration or new ventures business point of view, is if you could add to what you've done, once you have more data, of course, or right now, if you could quantify your uncertainties as either possibility of success or chance of success, whichever one you want to lean towards, to assign the impact of the lead zinc mineralization to each of the key petroleum elements. So such approach to exploration will then determine the next element to de-risk and what you need to de-risk it. So if it's a charge issue, as you rightly described, with the expulsion issues and the heat profile, then the question will be, what else do we need to do to further de-risk that, if that's the big thing? But what if that's proven? Then what about reservoir? What about trap and all that? So maybe having that quantitative approach to each of the elements and presenting that will form the basis for further exploration spend. And like you rightly said, maybe nothing there, but well done. Good job. Thank you.
Yeah, thank you, Giwa. So I'll just take one last question, and that's Dr. Ebio Mashallah. I see his hands up in the air. And Doc, over to you, sir.
Wow.
Hello, Doc. You have the floor now. Doc, maybe needs to unmute. So while we are waiting for Dr. Mashallah, looking at the... Doc, are you ready?
Can you hear me now?
We can hear you now.
Okay. Great job, great work. I understand his conclusions and I understand the way it's gone. What I would like to know, what my question is has he, or can we take this as a reference, this study, and then flip it? What happened or what's happening to the other side of the Antikynorum? that doesn't have so much of these intrusive bodies, and then all the changes and the activities from your volcanic intrusion as well as mineralization. How can we remove that and then see what should happen if these ones were not, except for the uplift that took place in Santonia? Can we reconstruct? If we reconstruct, you can then drop out the effect of all this volcanic stuff, and then you begin to see what area could be prospective without those additional intrusive bodies. I don't know if that makes.
Yes, it does, sir. It was done on this study, so it wasn't all the areas where we had wells, pseudo wells built, that were putting intrusives. So we could actually see charge even in certain parts, but the only issue was as a result of the anticlinorium and the uplifts.
Yeah,
you had the source rock basically just cease to generate or expel hydrocarbons.
What the question really is, what if the flip side of that anticlinorium is the western side? You were in the Afikpo side, right?
Yes, sir. So the Anambra Basin.
That map you showed us, you could see the repetition of those probably older or younger sediments on both sides, right?
In the Anambra Basin, yes, sir.
Good. So
it's been done, sir.
Have we then looked at the Anambra Basin side?
Yes, it's been done. The results are still coming out, but it's been done.
Oh.
For correlation, okay.
For that, because if you don't have all that volcanic activity there, you may have.
There's very little volcanic activity in that area.
Then you may have that's where to go.
Yes,
what I'm that your results will be able to say, hey, I have challenges here because I have headaches, I have the bush, everything overgrown, but this area is prime, and I think we have not done enough work. Then the focus will be there on that area that has no volcanic activity.
Yes.
Thank you.
Thank you very much, sir.
Thank you very much, Doc. And before I hand over back to the UK chairman, I mean, you could see from there, looking at the list of attendance participants, the diversity of the participation is a reflection of the interest of this topic. I see participants like Victor waking up as early as 5, 6 a.m. from the US dialing in. I see participants from Nigeria, from all over Europe. It's just a testament to the excitement topics like this generate now. If anything at all, this is a work in progress. It's not sealed yet. It can be sealed. What is evident from what we have heard and just from the lead that Dr. Mashala just gave now, it's very, very important that this conversation is alive. It's continuous. And for those of us that are in a position to elevate this conversation to NUPRC, we will, because it's important that it's brought to their attention that there's a war chest. Why you are still trying to decide where to spend this money. Some of them can be better spent acquiring more data in relatively yet to be ascertained petroliferous basins like these inland basins and the Anambra Basin as well. So, thank you very much, Astroloca, for allowing me to be back home to come and chair the session for a chapter I very, very much hold dear to my heart. And Gideon, well done. I see you guys are keeping the flag flying. Bimbo, well done. Keep the flag flying. And back to you, Chairman. UK coordinator.
Yeah, thank you very much, Musa, for sharing this session. And also, okay, can you hear me now?
Yes.
Okay, thank you, Musa, for sharing this session. And Alex, it's been a fantastic presentation from you. Thank you very much for accepting our invitation to make this presentation. I'd also like to thank all the people that attended this session, Dr. Marshall, KK, and a lot of others. So many people that I can't mention at this juncture, but thank you very much for coming. We hope that we'll be able to find other topics and other presenters that will attract this amount of interest. We have about 43 people on this call, but thank you for making our time for attending today. I'll hand over to the Publicity Secretary to make a few announcements. Publicity Secretary. Lenny?
Hello. Can you hear me?
Yeah.
Okay. Yeah.
Yeah.
Okay. Thank you so much. Yeah. I'll just do a quick run through the announcement. For those who have joined from the UK and are not members of NAPE, this is just to let you know that you can be a member. The fee is it's something that you could afford. It's around £15. So if you're interested in being a member, you can contact myself, me, or Dr. Chris Iwobi, the coordinator for how you can go about this. Of course, one of the benefits of being a member is there's an health maintenance organization scheme, and that could benefit also your families in Nigeria. NAPE and NMGS, we are organizing a mini conference that will take place on the 6th to 9th of September at the University of Lagos. This mini conference is for students, so attracting students. And there's currently a call for abstract, and the deadline for that will be, it's on the 15th of July. Acceptance letter will be issued on the 31st of July, and then deadline for extended abstract will be is the 21st of August. So if you're interested in this, please contact. You can take a note of this link, the link on the slide, and you'll find more details about the conference. NAPE annual international conference is also holding this year. Is the 41st, and that will take place on the 12th to 16th of November at Echo Hotel and Suite, Victoria Island, Lagos. The theme of the conference is repositioning the oil and gas industry for future energy dynamics. Lots of people have found value in this conference. A lot of technical meetings just like this, workshops, also management sessions, as well as networking opportunities. There are also opportunities for sponsorship. So if your company is interested in sponsoring any of the sessions or technical meeting, you can speak to Dr. Chris Iwobi or myself or me, or you could take note of the details that's on this flyer, and I will be happy to help. For the conference also, we've got call for abstract. The deadline for abstract submission is the 31st of July. Acceptance letter will be issued on the 31st of August, and then full paper is expected to be submitted on the 30th of September. So if this is of interest, you can take note of the sub-themes and you can submit your abstract. We also have technical meetings that will be taking place throughout the course of the year. One of the benefits of being a member is that you'll be sent notification via email of such event when it occurs. But we have an upcoming one taking place very soon at the end of this month, 31st of May at 11 a.m. The topic is resolving the mathematical products of seismic wave velocities. It's organized by NAPE Port Harcourt chapter. So NAPE is one body. So you can attend. It's going to be taking place online via Zoom, just like you're doing right now. And the speaker is Dr. Tamuno Nenyege Ofuri Dagogo. Is from the University of Port Harcourt. Also, NAPE Europe, UK Europe chapter, we're thinking of, we're organizing another technical meeting such as this. That will take place in 2 months' time, hopefully. And if you're interested in presenting, please you can contact me for more details, and we'll take it up from there. When the next technical meeting is going to take place, we'll communicate this to you via email and WhatsApp. Thank you so much for your presence. We really appreciate your time. Have a wonderful evening. Over to you, sir.
Okay, thank you. Thank you, Benny. Yeah. I don't think the NAPE president is on this call, otherwise would have asked for his comments, his observations. Is he on the call?
No, he's not.
Okay. Okay, so Benny, it's back to you again for.
Okay, so that's the end of our
doubling as a publicity on the tree today.
Yeah. So I think that's it for our technical meeting. Thank you so much. Yeah, the floor is open. I think, yeah, we can stop recording for networking. And yeah, you can leave at any time you want. Thank you so much for coming. We really appreciate your presence.
All right. Thank you very much. Very nice one. Great job.
So you guys are doing a good job.
Yeah, thank you, Alex.
Doing a good job.
Oh, thank you, sir.
Alex, what?
Thank you very much for having me.
Alex, are you based in UK now?
Yes, I am, sir.
Okay. So, I mean, for doing such a good presentation, when next time in town, I'll get you a ticket for a national game.
When you people have thrown your season away, that's not fair. I'm not happy. I was expecting you guys to win for the first time.
Well, when we did, I mean, you know, this city, they had an alien in their team. That guy called Alan. He's not a human being at all.
You guys are